And the price has got zero to do. Has she executed the Victorian books? Just give me a Why is it? So you only have one point, isn't it? So it's here, right? This one is, you're not putting any point here, you're putting any point. So you need to find a point that is connected to a plane that is connected to this point. That would be parallel to this axis and that axis. So which one? So which plane is that? So remember, so you can't same way that it's facing except this time. This side. Are we getting it? Okay. So the what's this? The that topic with the graph paper you practice, eh? I think that one will elaborate. Okay, so phase diagram, that's it, that's a compulsory question. So should we list the topics? Did we do that already for the exam? Atomic structure. Atomic structure. Okay, before classification. So that yeah. So number two becomes classification. So that's it. It's implication. Mechanical properties of material. So under mechanical properties, what did we look at? Also, we looked at tensile stress, isn't it? Tensile stress. We looked at compression. What's the stuff with compression? We looked at shear stress. Those definitions are there. Hmm? Hmm? No, as in, you know, that's in the notes. That you have. Did I share this with you? This one you have, right? It's soft copy. No, they're not additional notes. Where we have this non-destructive testing. I did. So I said that the tensile, when you have, let's say, an aircraft, I like to give that example. I think I gave it to you. And you need to take the integrity of a certain components, spare parts of an aircraft. Are you going to go and start compressing, hammering, start digging on the tensile and stretching it? Provided you don't have specimen, isn't it? You don't have extra material of that particular component for you to make a specimen. What are you going to do? That's why now we use the non-destructive testing. Okay, so there are about 3 or 4 that we normally look at. So you have the dye penetrants, magnetic powder, ultrasound also is used. Where is ultrasound commonly used? UV. In hospitals. So now, when this question comes in the exam, you cannot write about hospitals. This is material science. My full-time students always do that. No, when your bones are broken, because the other one is radiography. It's the same principle, okay, gamma rays, radiation, but the purpose is different. Okay, we're in material science, so the setup is not a hospital. I don't want you to be telling me about how maybe in case your bones are broken, go, then they'll check, then they'll find. No. The notes are there, you have them. I'll reshare if need be, but I think you have them already. Okay, so they are particular. So it's it's similar equipment, but this time we are looking at metals, because on the outside, a particular metal or a spare part will look okay, isn't it? Meanwhile, the inner parts of it have been compromised. There could be a void inside, and that will affect its strength. So how do you know that it's a void inside? You subject it to radiography. Okay, just the way that you're able to see the hollows and what in the, when you look at an X-ray for your chest, what do you see? The white parts signify what? Where the bones are, isn't it? And the hollow parts will be dark. So when someone has a TB, for example, how are they able to tell just by looking at the X-ray? Shit. Yeah, so when suddenly the dark parts are light, isn't it? It means that there's something there. There's some accumulation of something in the place that's supposed to be plain, a surface that is hardened there and it's becoming solid. That is a